An Oxford study has found that mixing and matching the coronavirus vaccines made by Pfizer-BioNTech and AstraZeneca, Oxford, generates a robust immune response against the virus.
An Oxford study said on Monday that a mixed schedule of vaccines, where a shot of Pfizer's COVID-19 vaccine is given 4 weeks after an AstraZeneca shot, will produce better immune responses than giving another dose of AstraZeneca. The study, called COMCOV, compared mixed two-dose schedules of Pfizer and AstraZeneca vaccines and found that in any combination they produced high concentrations of antibodies against the coronavirus spike protein.
So we were looking at mixed and match combinations of the Pfizer and AstraZeneca vaccines in our study, and we found that actually there are multiple options when using these vaccines, that you're not locked into using the same vaccine at the first and second dose.
The data provides support for the decision of some European countries that have started offering alternatives to AstraZeneca as a second shot after the vaccine was linked to rare blood clots. Matthew Snape, the Oxford professor behind the trial, said that the findings could be used to give flexibility to vaccine rollouts, but it was not large enough to recommend a broader shift away from clinically approved schedules on its own. The highest antibody response was seen in people receiving 2 doses of the Pfizer vaccine, with both mixed schedules producing better responses than 2 doses of AstraZeneca. An AstraZeneca shot followed by Pfizer produced the best T-cell responses and also a higher antibody response than Pfizer followed by AstraZeneca.
I think these mix and match type studies are really important when it comes to thinking about how these vaccines are going to be used globally. And other studies are looking at other vaccines, including the Chinese vaccines and the Sputnik V vaccines, because these are the vaccines that might be used more in low and middle income countries.
The results were for combinations of vaccines given at 4-week intervals to 830 participants. COMCOV is also looking at mixed schedules for over 12-week intervals, and Snape noted that AstraZeneca's shot was known to produce better immune responses with a longer interval between doses.
I'm now joined live from Bath in England by Dr. Bharat Pankhania, who's a senior clinical lecturer at the University of Exeter Medical School. Dr. Pankhania, thank you for joining us again today. Today, the Wimbledon tennis match started in England, tournament started, and it started with applause for the Professor Sarah Gilbert, for one of the scientists that discovered the AstraZeneca virus. And so it's appropriate today that we should be talking about some good news about a study involving AstraZeneca after the previous conversations we've had to have about problems which had come up. Can you tell us about this concept of mixing and matching vaccines? What does that mean?
So it's, of course, good news, and we've known about that it would be better to mix, and it is really nice to have it confirmed that it works and it works better. So for our viewers and listeners, let me explain. The AstraZeneca Oxford vaccine is made using a adenovirus, that's a sort of common cold type virus, but obtained from primates, in other words, chimpanzees, that sort of thing. So the reason we go to the primate route is in case we have met it before. So the primate one, we will highly unlikely to have met that virus before, and therefore we won't have antibodies against it. And then we take that virus and ask it to make mRNA, and then that mRNA makes the proteins and it makes the immunity. So that's how the AstraZeneca one works. But if you were to repeatedly give that AstraZeneca vaccine, you may make antibodies against the virus that is carrying the message. So if you were to have the AstraZeneca one first and then the Pfizer one to follow, you will have an immunity from different platforms. One is via the viral route, the other is via the nanoparticles that bring in the mRNA. And that, of course, it shows it works better.
And could you clarify for those who haven't yet picked up on what the significance of the mRNA are? Because this is a new technology in vaccines that I think we've seen for the first time in use now, and very exciting for the future of treatments.
Yes, it's very exciting, and it's really good news for humanity, because I bet you we will use many of these platforms for other things. So the mRNA is a very, very simple compound, and it is a code, and it only does one thing. It makes the spike protein. So the instructions in the little strand of messenger RNA are the instructions, and the instructions are to the ribosome, which is a little organ inside the cell, to make the spike protein. That is all it does. It doesn't interfere with your nucleus. It doesn't interfere with your DNA. The AstraZeneca vaccine is slightly different in that it gives the to your DNA to make the mRNA to make the spike protein. But apart from that, it's the same. So for our viewers and listeners, the mRNA is just a code, a small code, which instructs either your ribosome or your nucleus to make spike protein. And then our body recognizes the spike protein as alien, not wanted. Immune memory against it. And that's how the vaccines work.
Very interesting. Now, one thing I'm reading is that all the combinations prime the immune system. But this priming of the immune system, does that give us protection against other viruses, or is it specifically just against COVID-19?
Oh, it is very specific. It is very specific against SARS-CoV-2. Having said that, as we know, we get mutations and little variations and variants arising. But the immunity is such that it will cover those spike proteins which change a little bit, but they don't significantly change. Therefore, the immunity is against SARS-CoV-2, and so far, so good. It is effective against all the variants that we've had so far. Of course, the effectiveness is a little bit reduced, but it still works. Mm-hmm. And going forward, when we find a variant that is really dominant and really stable, we will reformulate the vaccines to cover the dominant variant that is circulating at that point in time. And that's not a difficult task. We just have to recode the mRNA to code for the new variant type of spike protein, slightly changed in shape. That's all. It's very good technology, and it works.
So is this study helping us to see forward into the future as to whether or not we might need a booster for against coronavirus?
Well, the study says the mixture works better. It doesn't necessarily answer the question about we need a booster. To answer that question will be to see how well the immunity is lasting beyond a year, for example. But I'm already very confident that immunity lasts beyond a year anyway, because we've seen it through natural infection. So that will be by testing people who have been immunized and see if they remain protected beyond a year. And I think they will be.
And I imagine that following this study, that further studies will need to be conducted to see which combinations of drugs will work together, and whether the new treatments which we discussed last week that are coming online are other tools to add into the box to help with the treatment of the pandemic.
Oh, absolutely. But, empirically, I knew that it would work, and it is really good to see it confirmed by a proper study. So I wouldn't be dwelling too much on which one is the best combination. My urgency is to get the vaccines in any combination as fast as possible to as many people as possible. That's the urgency. But the really good news is this. I expect we will be able to make better quality vaccines against other infections that so far we have not succeeded in doing. So I'm thinking about malaria, dengue fever, chikungunya, and even ordinary other infections for which the antibiotics are now not working. So I remain very positive on the vaccines front against several diseases, the exotic tropical ones, as well as the ones where the antibiotics have stopped working.
Well, I'm glad you just brought that up, because I was wanting to ask you, you've dedicated many years of your life, decades maybe, to communicable disease control and infectious disease management. So this pandemic, what has the course of this pandemic and the things that we've learned and developed, especially to deal with it, what has that meant for the progress of the field that you've been dedicating your life to?
We've come into the spotlight. So we are always backroom boys, and nobody really heard about us. Even my father would say, that's not what a real doctor does. So, you know, all the work that we've been doing with regard to prevention, protection, blue sky thinking, planning for the inevitable, planning for the unthought of, all of those things have happened. And with regard to the SARS-CoV-2 pandemic, all of these things we would have thought of, we did consider, and most people would have discarded it as, you're only dreaming, this is all theoretical stuff. And it has come to pass that all those things we thought of have actually happened.
So, so does this give you hope that in the future, I know you've looked at many other outbreaks, for example, Ebola and so on and so forth. Does this give you hope that when some other outbreak of some other virus or whatever comes along, that the world is now, I can't say immunized because that's the wrong word, is now ready to be triggered to deal with that in a much more proactive way than it maybe did for the COVID-19 pandemic?
I think so, because it has given a wake-up call to politicians, the purse holders, the money holders, because they've suddenly realized our importance. And I hope that they will invest in places like the Centers for Disease Control America, Public Health England, UK, ECDC in Europe, European Centers for Disease Control, and the World Health Organization, because we need the funding, we need that continuous new training of new people, etc. And the big wake-up call is for the politicians. We've always known that these things would happen, but most politicians are only there for 5 years and a 5-year cycle, so they have not invested as much as they should have in prevention, because prevention is a lot cheaper than fighting the pandemic, whereas we both see we've spent trillions upon trillions of pounds fighting the pandemic when actually we should have invested in prevention.
Absolutely, and that's the prevention. Sadly, doesn't if you do your job effectively, you don't see the results because there's nothing yes. to fight. But we know it's better to have a system to put out the fire before the building burns down. But that wasn't to happen. So we've just got. We're talking about the vaccines and how maybe a mix and match approach might come along, but how important is people not to take their eye off the ball and to get their vaccinations done and to take their personal responsibility still towards COVID-19?
So it's very important, and the vaccines will save your lives. The hurtful, the painful bit is that the rich nations have the vaccines and the poor nations do not have any vaccines, and therefore they've got nothing. So I hope that vaccine manufacture will be enabled so that more people can be immunized and lives saved, and that's what we need to do.
Yeah, and quite right. We were just talking the other day about how Africa is still in only 1 or 2% of people have been vaccinated. Haiti, I believe, nobody yet has received a vaccination. This is a terrible state of affairs, and we must put that right. Unfortunately, we've run out of time. Dr. Bharat Pankhania, thank you so much for joining us today here on The Edge. Thank you.